Hey, this video will serve as a primer of sorts to familiarize you with some of the units and some of the terminology that will be used in the unit on energy. So if you've taken a physics class, some of this will be review for you. And for some, this will be the first time you're seeing stuff. So just imagine that you're taking a trip from New York to Los Angeles and you're driving. Now somebody tells you that it's 2,790 miles. Somebody else says, hey, I thought it was 4,489 kilometers. Well, who's right? Or are you both right? Well, one thing that we're going to be doing this unit is using a lot of dimensional analysis. And dimensional analysis, we have addressed it. However, we're going to be doing a lot more with it. So dimensional analysis is, recall, it's converting from one unit to another. Both miles and kilometers are measuring the same thing, but they are doing it in a different scale. Likewise, if somebody says it's 40 degrees Fahrenheit in New York, and then somebody else says, well, it's 20 degrees Celsius in California, what does this mean? So we can also use dimensional analysis to convert these units as well. Now, when we're talking about these different units, just letting you know that the metric system is most of the world. United States, we use our own system, feet, pounds, Fahrenheit. You know, we're a little bit backwards. UK and Canada use a combination of metric and some of their own unique, like they'll use stone as a unit of weight. And I don't even know if it's 12 pounds or 20 pounds or something like that, but if you're like 12 stone or whatever, it says how much you weigh. Now, why does this matter? Well, most of the world uses the metric system. In the United States, we predominantly use, in our everyday life, we use our own customary system. And in science, we also use the metric system, which is Système International, a French term, but it just means metric system. So the unit of length, meter. For metric, we say feet. For mass, kilogram or pound, we both use seconds for time. Now, these units of mass can also measure force, as in gravity. However, that's for physics. That's not for AP Environmental. Now, in this unit, we're going to be using the unit of joule. And joule says that the energy equals force times distance. So the metric system uses joule, and that is 1 Newton meter. Newton meter. And a Newton is just a unit of force. And the customary system, don't even worry about this. I'm putting it here because it's, an equivalent, but we're never going to use this. But a foot-pound is literally a pound times a foot. So a Newton meter is multiplying, and these Newton and joule are named after people. So when you write out the word joule or the word Newton, it's lowercase. The symbol is actually uppercase. So a capital letter J and a capital letter N. Now, why does that matter? Well, because a calorie is actually, 1 calorie is 4.186 joules. So this is the mechanical equivalent of heat. When we're saying heat, we're saying calorie. Now, you've seen calorie before. It also means how much energy it will take to heat 1 gram of water 1 degree Celsius. So that is also what a calorie is equivalent to. So heating up 1 gram of water 1 degree Celsius is a calorie. This is something that was in your chemistry reference table as the specific heat of water. If you have your old reference table, pull it out, look at it. And a kilocalorie is how much energy it takes to raise 1 kilogram of water 1 degree Celsius. So a kilocalorie is the same thing as 1,000 calories. You know that because you understand your metric units. Now, when you see this calorie in our nutrition label, that is actually 110 kilocalories. So a potato, for example, might have 110 calories. Well, we're really measuring kilocalories. So how many joules are there in 110 kilocalories? Let's do the math. So we have our given, we have our unknown. Let's set it up. We have 110 kilocalories. Now we're going to do that conversion. So kilocalories, we're jumping over to calories and then to joule. We know that 1 kilocalorie is 1,000 calories. And we know that 1 calorie is 4.186 joules. So now what we want to do is put our units in there and we want to invert them so that the kilocalories will cancel out. And then we're going to take the other unit and put that one in there. And again, we're going to invert it so the calories will cancel out. Now we are left with joules. And how many joules it will take to heat up this, how many joules of energy will this potato provide? 4.6 times 10 to the 5th joules. And we got that by multiplying 110 times 1000 times 4.186. Now, another form of energy is a British thermal unit. And a British thermal unit is how much heat it takes, how many degrees Fahrenheit, or how much energy it takes to heat up 1 pound of water 1 degree Fahrenheit. So a BTU and a joule are also, they can be used to measure the same thing. I'll tell you that BTUs are used in the United States for our air conditioners. So a BTU is 252 calories, which is 1,055 joules. Great. Now another unit, or another measure, is power. And power is how much energy is actually flowing. Okay, so we have a joule per second, which is the equivalent of a watt. And you'll have your light bulbs will be measured in watts. Like if you have a 20 watt or a 50 watt or a 100 watt light bulb. And if you have 746 watts, that is the equivalent of horsepower. You've probably seen horsepower when you're talking about cars or automotives. Okay, again, a lot of information, not a lot of this is really that necessary. But this power is what we're going to be using. We're going to be using watts in this unit on energy. So how do we pay for this? Well, we pay for it in kilowatt hours. Now, let's look at this. So how many joules are in 1 kilowatt hour? Kilowatt hour is kilowatt times hour. And what they like to do a lot on this, on the FRQs is they like to start giving you kilowatts or megawatts, and then you have to convert it to kilowatt hours. Kilowatt hours is basically how much electricity are you using, because you're using this particular amount of power for this amount of time. Because I can have, so much energy going to my air conditioner, but if I only run it for 1 hour, it's a lot less power than if I ran it for 12 hours. So 1 kilowatt hour would be my given. So 1 kilowatt hour, and it's written kilowatt times hour. You'll see it written this way, kilowatt hour. But really what you're doing is you are multiplying. Okay, so these are the different ways that you're going to see it during this unit. Now what we need to do is figure out our conversions. Well, we have 1 kilowatt is 1,000 watts. Also, that cancels out the kilowatts. I'm still left with hours. Now I also have 1 watt is the equivalent of 1 joule per second. But when you have this per second as a numerator, this is where it gets a little dicey. Now my watts have canceled out. That's great. But now I have this joules per second. But since it's per second, that means that my second needs to really go on the bottom. So the joule, I reddened that out because that's my final, joules. Now it's per second, so I got the second on the bottom. Again, instead of it being per second and writing it on the top, this is the way that you would really see it. So now I have seconds and I have hours. So now what I got to do is I got to cancel out those seconds. So I know that 60 minutes are in 1 hour. Okay, great. Now I canceled out the hour. Now I got to get between minutes and seconds. And I got 1 minute, 60 seconds. Great. And then cancel out the seconds. Now all I have on the denominator are numbers 1 and no units. All I have on the top is the letter J for joule. And I have 60 times 60 times 1,000, which is 3.6 times 10 to the 6th joules. What I would like you to do is respond to this check for understanding. I know there was a lot of information there, but I'm going to give you a quick little check. All right. I thank you for your attention. I hope that this video was informative, and I will see you soon.